Find the 2000th derivative of f of x, which is equal to x times e to the negative x. So let's first find the first derivative. We find the first derivative of this function. Okay, we're going to use the product rule in addition to the chain rule. So if we take the first function, x, multiply it by the derivative of the second function plus the derivative of the first function times the second function, which is e to the negative x. Okay, so we're going to take x and then multiply it by the derivative of e to the negative x which is e to the negative x times the derivative of that exponent, which is negative x, plus 1 times e to the negative x. So therefore this becomes x times e to the negative x and then the derivative of negative x is negative 1 plus 1 times e to the negative x. So when we multiply this all out, we get negative x e to the negative x plus e to the negative x. So now we can factor out the e to the negative x, and what's left is negative x plus 1. Or we can just rewrite it as the following. It's going to be e to the negative x times 1 minus x. And that's going to represent the first derivative. Okay, now let's find the second derivative. So now we want to find f prime. So if the first derivative, f of x, is equal to e to the negative x times 1 minus x. So now let's find the second derivative of this function. So if we want to find the second derivative of this function, we're going to use the product rule plus the chain rule here. So we take the first function, which is e to the negative x, and then multiply it by the derivative of 1 minus x f prime, and then plus we're going to take the derivative of e to the negative x times 1 minus x. Okay, so we have e to the negative x, and if we take the derivative of 1 minus x, that's going to give us negative 1. Plus here, we're going to take the derivative of e to the negative x, which is e to the negative x, and then the chain rule, so we got to take the derivative of that exponent, which is negative x, times 1 minus x. Okay, so now we have e to the negative x times negative 1, and then plus e to the x times the derivative of negative x, which is negative 1, times 1 minus x. So we get negative e to the negative x minus e to the negative x times 1 minus x. So now what we're going to do is we're going to factor out the e to the negative x. So let's go ahead and do that. So we're going to factor out an e to the negative x of those two terms. What we have is minus 1 minus times 1 minus x. Okay, so now let's go ahead and distribute here. So if we distribute, we have e to the negative x. So we have negative 1 minus 1 plus x. So we end up with e to the negative x times x minus 2. So that represents the second derivative. Okay, let's find the third derivative. So we have f prime of x, or double prime of x, which is equal to e to the negative x times x minus 2. So if we want to find the third derivative of this function, then we're going to get the following. Okay, we're going to get the first function, which is e to the negative x, and then we're going to multiply that by the derivative of the second function plus the derivative of the first function times the second function, which is x minus 2. So we have e to the negative x times the derivative of x minus 2, which is equal to 1, plus here the derivative of e to the negative x is e to the negative x, and then we got to use the chain rule, so we got to find the derivative of that exponent of negative x times x minus 2. So therefore we have e to the negative x times 1 plus e to the negative x times the derivative of negative x, which is negative 1, times x minus 2. So if we multiply this out, now we get e to the negative x times 1, which is e to the negative x. E to the negative x times negative 1 gives us minus e to the negative x times x minus 2. Okay, now can we factor out an e to the negative x? And the answer is yes. So if we factor out e to the negative x, then what's left is the following. We have 1 minus parentheses x minus 2. So if we distribute that, we get e to the negative x times 1 minus x plus 2. So we get e to the negative x times 3 minus x. And that represents the third derivative. Okay, so let's take a look here. We can see that the pattern so far for the first derivative, e to the negative x, is 1 minus x. If you take a look at the third derivative, we have e to the negative x times 3 minus x. Second derivative is e to the negative x times x minus 2. Now let's find the fourth derivative. So we have the third derivative of x, which is equal to e to the negative x times 3 minus x. Now let's find the fourth derivative. So we take the first function, e to the negative x, multiply it by the derivative of the second function, plus the derivative of the first function times the second function, 3 minus x. So we end up getting e to the negative x. The derivative of 3 minus x is going to give us negative 1. Plus the derivative of e to the negative x is e to the negative x. And again, we got to use the chain rule, so we got to also find the derivative of that exponent, negative x, times 3 minus x. So we have e to the negative x times negative 1 plus e to the negative x, and the derivative of negative x is negative 1 times 3 minus x. Let's go ahead and multiply. So we have negative e to the negative x minus e to the negative x times 3 minus x. Now let's go ahead and factor out e to the negative x. So when we factor that out, we end up with negative 1 minus 3 minus x. So if we distribute that negative, we get e to the negative x, which is equal to negative 1 minus 3 plus x. So we end up getting e to the negative x times x minus 4. And that represents the fourth derivative. Okay? So we can see that there's a pattern here. Okay? And that pattern is the following. Okay, so if we wanted to continue, let's say we wanted to find the fifth derivative. We don't have to go that route anymore. We can say that it's going to be e to the negative x times 5 minus x. And then if we wanted to find the sixth derivative of x, then it would look like that one, which would be e to the negative x, which is equal to x minus 6. So, since they want us to find the 2000th derivative of that function, so that means this is going to be an even number. So f of 2000 of x would equal e to the negative x times x minus 2000. And that would be the derivative of that function.